Hello everyone, myself Dani N Jijo. I am from Assistant Professor from the Medical Imaging Technology Department, Yenepoya School of Allied Health Sciences, Yenepoya deemed to be University. So in this session, today we will be discussing about Thermoluminescent Dosimeter or TLD. So at the specific learning objectives mainly includes, at the end of this section, you will be able to understand the TLD, list out the components and its uses, explain the working technique for TLD and its advantages and disadvantages. So TLD or Thermoluminescent Dosimeter is basically a personal monitoring device which is commonly used to detect or monitor the radiation level. So it is the most commonly used device where we could easily determine how much amount of radiation level is present within a workplace. So TLD usually plays a crucial role in determining the radiation monitoring in hospitals, research facilities, nuclear medicine facilities, etc., where we could easily demonstrate how much amount of radiation is there. So by monitoring the proper amount of radiation level, we could easily provide better radiation protective measurements and provide a better, safer working environment for the staff as well as the public. Now, TLD basically works on a principle called as thermoluminescence. Basically, it is a process by which a material will emit light when it gets heated. So when the TLD is exposed to radiation, afterwards when the TLD is heated, it will emit the radiation energy as light, which is then detected by the device, and then it is converted into doses which we will calculate it. So basically how much amount of response, that is how much amount of light that is emitted by the TLD will be corresponding towards the amount of radiation that is absorbed by the TLD. So if a TLD is having high amount of radiation dosage, then it will emit high amount of light. So the response is always directly proportional to the amount of radiation absorbed. A usual TLD batch can cover a wide range of doses varying from 10 milliroentgen to 1000 roentgen. Now coming to the construction of TLD, TLD basically consists of two main parts, that is TLD card and TLD cassette. First, TLD card. TLD card is basically, it is a paper wrap which allows the visualization of user details and the period of its use. Usually, it will consist of whoever it is using, that user's name will be there, and usually the TLD is used for a 3 months time. After 3 months, it is then sent into authorized agencies such as ARB, where they will detect the amount of radiation level and then they will give it back. So for that specific time period of 3 months, the TLD card mainly allows the details of the user who is using it and from which month to next month. That is a 3-month period, they will demonstrate it. And it also consists of a pouch which will protect the TLD card from the effect of external environment, and it also consists of certain disc. So this is a pictorial representation of TLD card. It is usually coated by using a nickel coated aluminium, and it consists of a phosphor crystal which is embedded by the Teflon disc. So this is it consists of 0.8 mm thickness and 13.2 mm diameter. So this is the basic things regarding the TLD card. Now moving on to TLD cassette, basically it is made up of high impact plastic or polythene, and it basically consists of 3 filters, which mainly includes copper plus aluminum filter, which is used to detect gamma radiation, perspex filter, which is used to detect beta radiation, and an open filter, which is commonly used to detect X-rays. So these are the basic 3 filters that are mainly present within the TLD cassette. It also consists of 3 discs which will embedded between these 3 filters. So these are the major things regarding the construction of TLD. Now moving on to the working of TLD. The TLD basically works on 2 processes that mainly includes exposing the TLD and reading the TLD. So this is a pictorial representation. So before irradiating, it mainly consists of, as I mentioned earlier, the TLD card consists of phosphor crystal. In the phosphor crystal, it consists of valence band and conduction band, and the region between the valence band and conduction band is called as forbidden gap. So this much things are present in the phosphor crystal. So when the TLD is exposed to radiation, the electrons that are present in the valence band gains energy and they try to jump from valence band to conduction band. So while the electrons are traveling from valence band to conduction band, they will lose energy and they get trapped in the forbidden gap. So the electrons will travel from valence band to conduction band. So in between they will lose energy and they will get trapped in the forbidden gap. So this much things are happening while we are exposing the TLD. Now moving on towards reading of the TLD. When the TLD is heated, we are heating the TLD by using an instrument called as TLD reader. So after heating the TLD, again the electrons that are trapped in the forbidden gap will gain energy and they will escape from the forbidden gap and they will come back towards valence band. So while coming back to the valence band, they will emit energy as light. This light is detected by using the photomultiplier tube which is present in a TLD reader, and then we will get the digitalized signals. So this is a basic working regarding the TLD. This is I explained, that is exposing the TLD, where we will expose the TLD towards radiation and the energy is stored by the electrons, and these electrons will try to jump from valence band to conduction band where it will get trapped in the forbidden gap. Next, coming to reading the TLD is heated by using a TLD reader. Afterwards, when heated, the energy is transferred into the electrons that are trapped in the forbidden gap, from which these electrons will excite and they will escape from the forbidden gap and come back towards their original state or the valence band. So when these electrons are coming back to the valence band, they will release energy as light, and this light is detected by photomultiplier tube and converted into digital signals. So this is a basic principle regarding the working of TLD. Now, as I mentioned earlier about TLD reader, so TLD reader is basically an instrument that is commonly used to read the TLD card. So it basically consists of 4 things, that is a heater, photomultiplier tube, amplifier and recorder. So by using the TLD reader, we can easily demonstrate and depict how much amount of radiation dose is absorbed and how much amount of light is produced. This is a TLD reader that is commonly used for demonstration of TLD. Now coming to the working of TLD reader. So as I mentioned earlier, the TLD reader mainly consists of 4 major things, that is a photomultiplier tube, amplifier, recorder and a heating cup. So we are placing the TLD in a heating cup where we will heat the TLD. So as I mentioned in working, the electrons will gain energy and they will escape from the forbidden gap and comes back down to the valence band. So when they are coming back to the valence band, they will release energy as light. So light is produced. This light is detected by using photomultiplier tube. The function of photomultiplier tube is that it will convert this light into electronic signals or electric signals. So these electric signals are then passed on towards an amplifier where it will amplify the signals. Why we are doing amplification is that even a minute amount of radiation is easily detected by using the amplifier. So whether it is high radiation dose or low radiation dose, it can be easily detected by using the proper amplification of the signal. After amplifying the signal, it is then passed on towards recorder, where recorder will digitalize the signal and convert it and store the data. So these are the major things happening in the TLD reader. There are the different types of TLD badges which are commonly used in worldwide. Most commonly used is chest badge, which is worn at the chest level by all the personnel who are working in the radiation field. Now coming to the second one, wrist badge, it is used when during the procedures or any other things. And last one is finger dosimeter, which is commonly used by in fluoroscopic or interventional procedures, where the commonly used by surgeons or others who are frequently in C-arm operations where it consists of high amount of radiation dose which is emitted during the surgeries, where they commonly use the fingers to do the surgeries. In such cases, we will commonly use a finger dosimeter. So these are the basic major TLD badge types which are commonly used in worldwide. Now coming to the advantages of TLD. TLD's basic advantage is that it is not affected by humidity, pressure or any normal temperature. No fogging is present. It is usually small in size and chemically inert, so we can use it anywhere and anytime. It can store data for longer period of time and it is reusable. As I mentioned earlier, every 3 months we can reuse the TLD. Coming to the disadvantages, it does not provide a permanent record and it does not give any instantaneous result. We should do the process as I mentioned earlier, and instrumentation for TLD badge is very expensive. That for TLD reader and how to reading all the mechanisms requires quite expensive and it needs proper calibration. Now coming to the summary, TLD indeed plays a crucial role in demonstrating a safer working environment for the staff as well as for the public. It allows the proper radiation monitoring levels and proper increase in the radiation protective measures that can be given towards the workplace area for the staff as well as for the public who are embedded. So basically, TLD is the most commonly used personal dosimeter. By providing a proper TLD units, we could provide a better radiation protection and ensure that a safer radiation exposure levels is given towards the individual as well as the environment. So TLD can be placed at the chest level, wrist level as well as a finger dosimeter. After exposing of the TLD, it is given into the TLD reader where we will do the reading of the TLD, and we will get how much amount of dose is present within the user. So basically, it is a most commonly used personal dosimeter where we can provide a better, safer environment for all the personnel, including staff or the public who are working under radiation field. These are my references. Thank you.